Q6597-1. When the angle of attack of a symmetrical airfoil is increased, the center of pressure will A. Remain unaffected. B. Have very little movement. C. Move aft along the airfoil surface. The correct answer is B. When the angle of attack of a symmetrical airfoil is increased, the center of pressure will have very little movement. A symmetrical airfoil is designed in such a way that its shape is the same on both the upper and lower surfaces. This means that the airflow experiences equal curvature on both sides of the airfoil. When the angle of attack is increased, it means that the airfoil is tilted upward with respect to the oncoming airflow. This change in angle of attack affects the distribution of air pressure on the airfoil. In the case of a symmetrical airfoil, the center of pressure is located at the midpoint of the chord line. The center of pressure represents the average location of the pressure forces acting on the airfoil. Due to the symmetrical shape of the airfoil, the pressure distribution on both the upper and lower surfaces remains relatively balanced even with changes in angle of attack. As a result, the center of pressure does not experience significant movement. While there will be some changes in the pressure distribution and the center of pressure due to the angle of attack, these changes are minimal for a symmetrical airfoil. Therefore, the center of pressure will have very little movement as the angle of attack is increased. This characteristic of a symmetrical airfoil is important for maintaining stability and predictable aerodynamic behavior during changes in angle of attack. Q6597-2. In a helicopter, drag is a force parallel to the A. Rotor blade plane of rotation due to coning angle. B. Relative wind and perpendicular to lift. C. Angle of incidence and perpendicular lift. The correct answer is B. In a helicopter, drag is a force parallel to the relative wind and perpendicular to lift. When a helicopter is in flight, it generates lift by rotating its rotor blades. The rotor blades create a relative wind, which is the airflow experienced by the blades as they move through the air. Drag is a force that acts opposite to the direction of the relative wind. It is caused by the resistance of the air against the helicopter's forward motion. The direction of drag is perpendicular to the lift force generated by the rotor blades. Lift is the upward force that opposes the force of gravity and keeps the helicopter airborne. Since drag acts parallel to the relative wind and perpendicular to lift, it states that drag is a force parallel to the relative wind and perpendicular to lift. The relative wind is determined by the helicopter's forward motion and the motion of the rotor blades through the air. Drag opposes this relative wind and acts in a direction that is perpendicular to the lift force. Understanding the forces of drag and lift is essential for helicopter pilots to control the aircraft's performance and maintain stability during flight. Q6599-1. During flight, if you apply cyclic control pressure which results in a decrease in pitch angle of the rotor blades at a position approximately 90 degrees to your left, the rotor disc will tilt A. Aft, B. Left, C. Right. The correct answer is A. During flight, if you apply cyclic control pressure which results in a decrease in pitch angle of the rotor blades at a position approximately 90 degrees to your left, the rotor disc will tilt aft. In a helicopter, cyclic control is used to control the pitch of the rotor blades at different positions around the rotor disc. The cyclic control is typically operated by the pilot's control stick and allows for precise control of the helicopter's movement. When you apply cyclic control pressure to decrease the pitch angle of the rotor blades at a position approximately 90 degrees to your left, it means you are commanding the rotor blades on the left side of the rotor disc to reduce their angle of attack. As a result, the lift generated by those blades decreases relative to the lift generated by the blades on the right side of the rotor disc. This creates an imbalance in lift, causing the rotor disc to tilt aft, or in other words, tilt backward. The tilting of the rotor disc affects the helicopter's attitude and results in a change in the aircraft's pitch angle. By manipulating the cyclic control, the pilot can control the direction and magnitude of the rotor disc tilt, thereby controlling the pitch attitude of the helicopter. In this case, stating that the rotor disc will tilt aft when you decrease the pitch angle of the rotor blades at a position approximately 90 degrees to your left. Understanding the effects of cyclic control inputs and their influence on the rotor disc tilt is crucial for helicopter pilots to achieve precise control and maneuverability during flight. 6599-2. Tip path plane may be described as A. Meaning the same as rotor disc. B. Being proportional to disc loading. C. The longitudinal axis of the rotor disc in horizontal flight. The correct answer is A. The tip path plane may be described as meaning the same as the rotor disc. In a helicopter, the rotor disc refers to the circular path traced by the rotor blades as they rotate. The rotor disc encompasses the entire area swept by the rotating blades. It is an imaginary plane that is perpendicular to the rotor hub and intersects the rotor blade tips. The tip path plane, on the other hand, is the plane formed by connecting the tips of the rotor blades as they rotate. It represents the path followed by the tips of the rotor blades during their rotation. When considering the tip path plane, it is important to understand that it is essentially the same as the rotor disc. Both terms refer to the same concept of the circular path traced by the rotor blades. Therefore, stating that the tip path plane may be described as meaning the same as the rotor disc. Understanding the terminology related to rotor systems and their components is crucial for helicopter pilots and technicians to communicate effectively and accurately describe various aspects of helicopter flight dynamics. 6600. The lift differential that exists between advancing and retreating main rotor blades is known as A. Translational lift. B. Dissymmetry of lift. C. Translating tendency. The correct answer is B. The lift differential that exists between advancing and retreating main rotor blades is known as dissymmetry of lift. In helicopter flight, the main rotor blades experience different airspeeds and angles of attack as they move through the air. This is primarily due to the combined effects of the helicopter's forward speed and the rotational motion of the blades. As the helicopter moves forward, one side of the rotor disc is advancing into the oncoming airflow, while the other side is retreating and moving away from the airflow. This results in a difference in the effective airspeed and angle of attack between the advancing and retreating blades. The advancing blade experiences a higher airspeed and therefore generates more lift, while the retreating blade experiences a lower airspeed and generates less lift. This difference in lift between the advancing and retreating blades is known as the dissymmetry of lift. To compensate for the dissymmetry of lift and maintain balance, helicopters incorporate various design features and control mechanisms. These include blade flapping, cyclic and collective pitch adjustments, and rotor blade coning. Therefore, stating that the lift differential that exists between advancing and retreating main rotor blades is known as dissymmetry of lift. Understanding the concept of dissymmetry of lift is essential for helicopter pilots and engineers to effectively manage the rotor system and ensure stable and controlled flight.